All right, to start off question set 5, we're going to start by looking at indirect proofs. Indirect proofs can be useful when the conclusion is a negative statement. Example of an indirect proof. Given the measure of SCR does not equal the measure of angle CSI. So we're trying to prove that parallelogram RISC is not a rectangle. Well, we start with the end in mind. We start with an assumption, the opposite of what we're trying to conclude. So we say, well, parallelogram RISC is a rectangle. That's an assumption. The measure of angle the measure of angle SCR equals the measure of CSI, which equals 90 degrees because definition of a rectangle says that all angles are 90-degree angles. But we were just given that the measure of SCR does not equal the measure of CSI. That was what we were given. So therefore, Therefore, parallelogram RISC is not a rectangle because we were led to a contradiction in steps 2 and 3. 1 said that they were 90 degrees and that they were equal to each other. In 3, it says that they were not equal to each other. So therefore, this cannot be a rectangle because we came to a contradiction. It says, math tip, an indirect proof begins by assuming the opposite of what you're trying to conclude. The assumption is used as if it were given until a contradiction is reached. Once the assumption leads to a contradiction, the opposite of the assumption, which is the original conclusion, must be true. Let's look at number 7, and we're actually going to do question number 7 together. It says, complete the missing reasons in this indirect proof. Given WT does not equal TS. And we're asked to prove that quad wish is not a parallelogram. So we start with the assumption, which is the opposite of the conclusion. So we start with parallelogram wish. This is what we call an assumption. Okay. WS and HI bisect each other. Well, that is one of our properties of a parallelogram. So we're going to put diagonals of a parallelogram bisect each other. Well, if they bisect each other, WT must equal TS and HT must equal TI. That's the definition of bisect. Here in the next line, it says WT does not equal TS. Where did that come from? Oh, that was my original given statement. So what did 3 and 4 just do? 3 and 4 just contradicted each other. So quad wish cannot be a parallelogram. The assumption led to a contradiction between statements 3 and 4. So we started out by trying to assume that what we were trying to prove was false. So opposite of what it is. So we said that wish has to be a parallelogram. That's an assumption we're making. Well, we know by properties of parallelograms that WS must bisect HI. and HI must bisect WS. They bisect each other. Well, definition of bisect says that the two pieces that create that long piece equal each other, right? But we were also told at the very beginning that WT did not equal TS, which this says they do equal, this says they do not equal. So therefore, when we made the assumption at the very beginning, we were wrong because it came to a contradiction of itself. On to the next set of questions.